Symposium. This year's theme is an especially timely one: inflation, the new foodborne illness. The GFSS is a forum in which we share timely and pertinent food safety topics and includes partners from academia, industry, and government at the provincial and federal level. Today is the third session titled Alternative Proteins. Are we there yet? My name is Valeria Neto, and on behalf of myself, my co-moderator, Emefa Monu, and the entire GFSS organizing committee, I hope you enjoy today's session. First, a few housekeeping topics. I'm sure these are familiar to everybody, but just as a reminder, cameras and microphones are off. Please use the chat box for questions during the QA period, and the questions will be asked after each presentation. And as I mentioned, this session is being recorded, and if you'd like a copy of the presentations, please email Susan Sabatini, and she will provide you with the copy. Today, we have two speakers. Our first speaker is Dr. Yanning Huang. Dr. Yanning is the Global Director of Quality Control at ADM, where she leads the global initiative of standardization, optimization, and continuous improvement of ADM quality control processes. Dr. Yanning has a PhD in microbiology and a minor in biotechnology. She has an extensive experience in building global food safety programs, for example, EMP, Food Safety Plan and Hazard Control Plan, Allergen Control Program, Positive Release Program, Process Validation, Chemical Contaminant Monitoring Program, etc., and leading a high-function team. Dr. Huang has successfully led the global allergen control program and food safety risk assessments for plant-based products in microbiology, ingredient, chemical contaminants, and packaging. Dr. Huang is also the chair of the International Association for Food Protection, Plant-Based Alternative Products Quality, and Food Safety Professional Development Group. Please welcome Dr. Yang.
Good morning, everybody. Let me share my screen. Can you see my screen?
Yes, we can. Thank you.
Okay. So good morning, everybody. I'm very glad to be here to share a little bit experience of my stories in terms of handling novel food. Particularly today, I will share some in terms of the insects and also plant-based. I believe my next partner, Elliot, will share in terms of the couch meat. I think we both will cover most of the novel food. So I'm from ADM. I hope most of you know what ADM does. So at ADM, we do believe our slogan is unlock the power of nature to enrich the quality of life. So there are three critical concepts at ADM. The first one, we believe food security. So everyone should have the right to food. They should have the access to food too. I don't know if you guys watch news. So I think UN just published November 15th, just published right now, we have 8 billion, right? 8 billion people on Earth. Based on current estimate, so to meet the need of the growing population, we will need to produce more food in next 40 years, more than we have in the past 8,000 years collectively, sustainably. So, which means we will need more ways to produce food to feed people. That The second, we believe, is sustainability because we need more food. So the future of food will not look like the past, right? We have to shift many paradigms, develop and scale many new technology, like we will talk about plant-based fermentation, cultured meat, climate solution, all this to feed that growing population and establish a more sustainable, healthier, and a more secure food supply chain. The third one we believe is we need to produce food like to help people in terms of health and well-being. ADM last year did the research to show that 77% of the consumer want to do more to stay healthy in the future, more with a focus on plant-based protein, gut health, extracts, natural flavors and colors, so on and so forth. And if you guys also read the Food Business Wire, we actually last week, ADM published the global trend, 8 global trend on human nutrition and nutrition innovation. I list 6 of them here. So then number 1, so it's not on order, but they are list 6 trend. The first one is balanced wellness. Globally, 79 of the consumer believe that supporting their mental health has a positive effect on their overall health and wellness. Plus, 48% of the global consumer plan to adjust their mental well-being over the next year, making the issue among their top concern after the immune function, digestive, and heart health. So balanced wellness is one of the trends. The second is earth-friendly. Globally, 49% of the consumer claim to have changed their diet in the last 2 years to live a more environmentally friendly lifestyle. So that's a lifestyle. That's another trend. The third one, I think if you watch FDA just published the final rule on food traceability, right? Consumer want to listen. Consumer want to know where their food come from, who made it, and precisely is what ingredients are included. 42% of the global consumer have become more trusting of the environmental claims made by companies, products, and brand in last 2 years too. We are here today. We talk about alternative proteins. So one of the trend is expanded proteins. More than half, exactly is 52% of the global consumer now consider themselves as flexitarian or even say it's alternative protein into their diet. Within that 52%, nearly 2/3 are defining their eating style as try to use more plant-based food. So that lead to more demand for expanded protein options. This number 5 is proactive personalization. So based on our research, 63% of the global consumers say they are interested in food products that are customized to meet their individual nutrition needs. On top of that, 55% of the consumers say they are willing to spend more money on function food that can support their health goals. The number 6 is social impact. So consumers are demanding company practice fair and humanity treatment of people and animals involved in every aspect of the production. 40% of the consumers seek out brands that can guarantee farmers have been treated in an ethical way. Another tool I didn't list here is modern pet parenting. That's pet. And another one is experiential eating. They want to more personal and experience. A lot of people say they want to try food they never tried before. So let's just give you an overall, we just published. If you want to, there is a link and you can search for it to find what we published in terms of the global trend on nutrition. Here is just a snapshot of protein profiles of ADM. So you can see we have like a pure just soy, pea, wheat, and also have functional systems, TVP, texture, soy protein, isolates, SPC. So all kinds of solution and system. If you are interested, you can look up on this too. So what I'm going to talk about is today is in terms of food safety, particularly in terms of microbiological, chemical, allergen, like what I have encountered before, and I will share a little bit experience how we handled it. I will guarantee you I don't have all the answers today, but I would share what I have done before. At the end, I will also, because each one of these have at the end have a challenge in terms of testing, and I want to ask as a community come together to actually tackle this testing piece of it too. So that's just overview about what I'm going to talk about today. First, I want to share a little bit in terms of microbiological risk and how we have handled in terms of microbiological risk. The first one list is also in terms of trend, edible insects, right? You can see more and more in terms of farmed, not in terms of the wild. I think I'm from China. Yes, they are like a wild caught, like in terms of insects, long time ago, right? People will eat the insects. But so today's talk, I will just focus on farmed, mainly cultured, like the insects in farms instead of the wild ones. And you can see in terms of list also is we talk about raw, right? Eat as a raw and eat as a cooked. They are different risk in terms of the insect protein. So on the right, you can, that's all the reference you have seen like a FAO just recently published in terms of consume of insect protein. That's the list of the top 8 insect protein consumed in different culture in different countries. And the food safety aspect of it. So I will share a little bit from the published data. So from UK is the food safety standard, right? It says it's low safety risk from edible insect product. That's found by UK, but based on that report, you also can see, because in UK, that's not a trend of not widely consumed. So the data is limited. They are only about 2 years of data in terms of how they identify the risk. But if you look at EFSA, so EFSA's report also shows like a Staphylococcus and Bacillus could be a risk, and it depends how you handle it. Especially, particularly, is in terms of how do you farm of rearing the insects. So, for example, if you are using egg carton to as a substrate to culture the insect, then Salmonella and Campylobacter can be a risk for the insect protein. Why? It's because when you use it, and then they also, because the egg carton come from the poultry, and it could be also cross-contamination. Another big one is because they actually, when they farm it, it could be cross to animal, right? It could be poultry, cow, or something else in the same farm. So that's sometimes cross-contamination for Salmonella and Campylobacter. So based on the FAO report, you will see the most concern in terms of insect protein is actually Bacillus and Clostridium in terms of spores. So why that is because after you cook it, you need supposed to cool it. So the spore forming of the spore will be a concern in terms of Bacillus and the Clostridium. But overall, based on all this, insect protein at the end of the day is if you do actually be able to employ good hygiene practice, including handling, harvesting, processing, storage, and the transportation. It will mitigate the risk in terms of the micro. None of this is a high risk. It's in terms of how you handle it. It's like any other food, right? This one, I want to just overall talk in terms of the micro for plant-based protein. So plant-based product, this is just one example I want to share with you, because in terms of micro control, you have to wait from the beginning to the end. It's a collectively collaboration between each different party. From me, it's you, from your supplier to your consumer and to your processor. Each one of us take one role in this whole food supply chain. So I will talk about in terms of sourcing, because I have actually worked in Danone and ADM. So Danone is a consumer goods. ADM, I will consider as an ingredient company. So the first one thing is when you do, I know when you source it, right? You said, I did my supply approval, I did my supply control. One thing I noticed very particular in terms of processing when you're sourcing, have you asked the question, said, is this ready to eat? Not ready to eat. Is this kill step validated or not, right? Because when you are source raw flour, instead of ask the supplier to test everything, please test salmonella, E. coli, and listeria. I believe the right question is ask, do you have a process control? Is it a ready to eat ingredient? No matter it's you soy flour, soy isolate, a lot of people use wheat and all this from plant-based. Ask the right question, right? So if you are using add a cold press bar, or if you are add afterwards into your ready-to-eat drink, you better buy a ready-to-eat ingredient, right? Instead of just get it. And so that's in terms of a sourcing. That's a very critical in my mind in terms of at least how I see it in terms of sourcing. Apparently, right, when you source, you have a specification for your ingredient. What I'm here talk about in terms of specification, I would like to ask is in terms of specification, is it a low moisture food? When you buy it, buy a soy flour or buy a soy protein isolate, right? That's a low moisture food. However, in that you want to say, okay, I'm going to add into a milk or into a plant-based milk to add the protein, or add into a yogurt, or add into something else, even a veggie burger. Do I change what activity? You see where I'm going? It's when you are, right, as an ingredient, it's a soy flour, it's a low moisture food. It could have spores. That's not a hazard at that time, or not a risk. But when you add what activity, change the what activity of it, would it change? But at the same time, what's the right specification? When you said my bacillus spore less than 10, try it, right? Can you get that ingredient? It's come from the soil. It have high microflora, right? So is it realistic for me to set a spec at less than 10 or less than 100? Can I get that, right? That's why I said it's a collaborative relationship between your supplier and you to understand what's the natural of the ingredient. Is it low moisture? Is it low acid food? Whatever it is, consider the ingredient and also the end use of it. Another one, okay, I got the ingredient, I mix everything together. Now I go to batch it, I go to heat treat it, right? If you have handled the plant-based, you know. If you are used UHT before, you try your plant-based, your temperature time may not apply there because they are high protein, easily get burned. So now I cannot use UHT. I have to use HTSD of something else, lower temperature. Can I still get the control of it, right? That's in terms of heat treatment. The next is fermentation, right? If you, okay, now I go to fermentation. If you are plant-based, you have to handle it like I know, right? How do I control my bacillus? Well, short term, then I don't grow to a level produce toxic. When you do plant-based, can you still shorten you, let's say your fermentation time within a certain hours? Typically, if you are plant-based, you have an extended fermentation, meaning longer fermentation. And you also need to consider your micro in terms of my longer fermentation will not grow to a level, right, to have a potential hazard. So fermentation, that's another one you need to consider in terms of your plant-based. What's your time and temperature, and what's your pH? And another big one in terms of plant-based, it works for one matrix, it may not work for another one, right? In terms of your fermentation, it works for a vanilla, it doesn't mean it works for a chocolate. If you have experience in this, you will say chocolate take longer. So the last part of it, what I'm saying is in terms of packaging, right? Packaging, not every process is aseptic packaging. It could be an ultra clean packaging of other. Consider you package too. So overall, I want to convey a message today is when you consider your plant-based, work with your supplier, work with your process, work with your PD people to understand each one of the steps, and then across the value chain work together to control the micro. It can be controlled. It's just need to work together. Don't set up a spec not able to achieve. So next, I want to switch the gears into the chemical contaminants, right? In terms of different pesticides, heavy metal, and all the other. So what's the difference? What's the unique about chemical contaminants compared to plant-based? Then your normal, let's see, cow and animal-based. Typical one, it's region, right? As you can see, like a cow, I can source in US or source in Canada. But when we are talking about all these different macaroons, all these different source of ingredient, you can source from anywhere in the world. We are a global village. You source so many different ingredients, so different region, right? They are, and so many different ingredient is sourced from different regions. So what does it mean, different region? In terms of chemical contaminant, different region first have different regulation. In US, we have our famous California, right, Prop 65, and they are countries, they are actually maybe the food safety management system is not as developed as a developer country. So they are other consideration when they may not even consider imagine heavy metal or pesticides. Right? When you source it, you do need to remember that's from some region they don't implement this limit. Another one is in terms of less chemical contaminants, it's in terms of population, right? A lot of this food is targeting for toddler, infant, or they are targeted for adults. One thing I want to remember is target population. When you talk about adults, they also have different regulation. If you look it up in US and in Europe, the toddler is different age. So that will, based on that, will set up your limit for chemical contaminant. I took here, it's an aflatoxin example. So when you consider that aflatoxin, when you are targeting infant, you have a different limit than you as an adult. So that's something you do need to consider in terms of chemical contaminants. So the next one I want to talk about plant-based, the ingredient matters, right? So what do I mean? Ingredient matters. First of all, ingredient matter means the parts. I use here as a coconut as an example, right? Your coconut milk come from the coconuts, the fruit by itself. But do you know if you I put a palm sugar, basically that's a coconut sugar. Do you know coconut sugar actually come from the palm? So why does that matter? Because if you are from the palm, not from the fruit, that's not an allergen. You are from the food, coconuts considered as an allergen in terms of how do you manage it. So your coconut sugar, can you call it coconut sugar, palm sugar, whatever you call it? You will see UPD people will have an argument with you. When you call it coconut sugar, and you cannot label it, you have like a coconut as an allergen over there, right? So that's a dilemma. That's why it was kind of, when you consider plant-based, you need to consider the different parts. Which parts I'm using? I'm using palm, I'm using flower, I'm using the fruit, or I'm using the roots. Second is the form, right? In terms of what form of the plant-based are you using it? I know I eat ginger every day, right? But it's a fresh ginger and I can eat, let's say 1 serving, 2 serving. Now we are making it as a ginger powder. It's a concentrated form. How much, how many can I use at that concentrated form? Why? Because it does matters. I think a lot of you heard about the turmeric in Europe, right? The thing in terms of when the form changes, they are concentrated, they may have different reaction. People eat it. And another thing it matters is how you use it in your food, right? You can use it as a powder. I put a picture here is actually turmeric, right? You can use it as a turmeric powder. You can use it as a USP, a supplement. You can also use it as a food coloring. How you use it impacts how do you do your risk assessment, because they change how you do your risk assessment in terms of the ingredient. The last part of it is the dose matters, right? Like right now, you will see things you don't even imagine, like it's in there, like coffee yogurt, right? You add coffee into the yogurt. Like for me, I'm a very sensitive people to coffee. I cannot drink it. But when I take a yoga, I don't actually consider there is coffee in it. That's the different form, different dose, different use, and different parts you need to consider in terms of your chemical contaminants. Last, I want to very briefly talk about my favorite subject in terms of allergy. So from plant-based, so what can we consider in terms of allergy? From the beginning, it's how you design your label, right? UPD people maybe want to have all kinds of claim onto your label. One of the typical one is soy-free or other-free, right, on your label, or even vegan, right? Vegan, it's a claim on it. However, a lot of people consider that's an allergen claim, right? Because they think, oh, they are vegan, so they are no egg, no milk. Is it true? Did you check your cross-contamination of it? So that's when you design your label. You need to consider, what did I put on my pictures, on my claims? The second I want to talk about in terms of allergen cleaning. Allergen cleaning, so when you manufacture it, when you do your allergen clean, consider it. When you do your milk come from cow, you can clean very well because it's a liquid and your normal CIP will work. But when you consider your almond milk, it comes from almond butter or almond paste. Is it still can run 24 hours, 48 hours, 72 hours? Trust me, it takes way more stronger CIP to do your allergen clean. And I put an ice cream here because you have particular allergy, you also have your liquid allergy. So how do you handle that? So that's in terms of allergen clean, consider your CIP. It will be a challenge in terms of when you produce plant-based. Last is in terms of consumer. So why do I put here? It's because you can see I did review in terms of the trend, but a lot of consumers switch to plant-based. It's because they are allergic to cow's milk or allergic to something they are looking for alternative. So they are highly educated in terms of the allergy. right? Because they do have to switch into an alternative choice. So one of the things I put here in terms of allergen is cross-reactivity. Most of you may already know, right? When you are insect protein. So if you are allergic to shellfish, most likely based on the data, they have some cross-reactivity. I think some of you also see, like if you are allergic to peanut protein, it's be careful with the pea protein, right? Because they most both of them from lagoon. But a lot of the study already shown they are not cross-reactivity between the pea protein and peanut allergy. But that's something in terms of allergen when you consider all this insect protein, plant-based protein, what can be, right? The last one I want to list is relate to allergen, but not that much, right? But allergen-free claim. That's obviously allergen would debate. Does this belong to an allergen or not allergen management program? So I want to give you some example, right? For plant-based, like I said, a lot of people switch to it is because they are allergic to dairy. They are allergic to cow's milk. So a lot of the product have a daily free claim. So if you have that and you do need to check your ingredient, I want to particularly point out is the culture. The culture you use to fermentate your plant-based. Ask your supplier what media do they use. Do they use milk as a media? So if they do, can I still do daily free claim? So I know FDA have a definition in terms of daily. So that's something you do need to check before you do a claim. I list some example here. There are many, many other. That's why I said it's sometimes it's allergen claim, sometimes it's not, like a carcinogen free, artificial free, flavor free, all this. Another one is in terms of how do they do free claim, right? They will say soy free, no soy, or no added ingredient, all kinds of. But another big one in terms of allergen free claim is agriculture claiming green, right? Your soy, your pea, your peanuts, even your flour, right? They can grow in the same field. Maybe in your production facility, you don't have it. Can you also check your farm? The source of it? Do they have practices like not rotating the farming practice so you don't have cross contamination of agriculture from commingling, right? Come from the farm. So I already mentioned it, like a vegan free. The last one I want to see, you can see there are somebody claim nuts free. Can we claim that? In Canada, how many nuts do you have? And in US, how many nuts do you have? I know in US, FDA lists 21 nuts. You don't even have that kind of testing and check to check all the nuts, right? Can you claim as a nuts free? Or I can claim one nuts free, not all the nuts free. So that's overall in terms of allergen. I want to you, like when you do this kind of claim, do check in terms of each one of this. Out of all this, each one of this come at the end, you do have something need to remember, right? For each one of this, I want to say, okay, at the end, we come to the testing. Should we do testing or not do the testing? Is testing the right way to do of the solution, right? Testing, need to remember it's a verification. All the control have to come from you, food safety, you processing, you sourcing, you supply control, sanitation control, and you other allergen control, right? So all the other control will take in place. Then we come to testing to verify if my control is working or not. So I'm going to provide you with some challenge when you do testing and how you handle it, right? So for micro, when you come from like a plant-based of insect, it's come from the soy or come from the farm. Remember, come from soil, they do have high background flora. How do I not have interference from other non-pathogenic, but it's a good bacteria over there, interference? So when we are talking in terms of micro, right, I mentioned in terms of the insects, they are bacillus, they are Clostridium, all this as a potential risk. Then you want to test for it. Now you have to consider is, okay, I test bacillus, that's actually longer, right? Longer turnaround time than your salmonella, than your listeria. Do you have warehouse storage? Can I handle that, right? The longer turnaround time, how long can I, in terms of my supply chain? Allergen, the same thing. I put it here, it's mainly because for you cows, you look for proficiency test. Cow's milk, you can find it, right? Milk easily find a matrix, find a standard. But when you are talking about maca roots, turmeric powder, and all this, how do I have a reference standard? How do I validate that matrices? Chemical is the same thing as chemical unique is because, like I said, they are different region. Then you have all we call it emerging risk, right? Have you heard about 3-MCPD, MOH, PFAS? That's the popular one for FDA right now. All these emerging ones, do you even have an official method? Do you know if the method work for your matrix? It work for animal-based, does it work for plant-based? So all this need us as a community to work together to be able to establish what's the standard reference material for us to do a proficiency testing. We cannot, each one of us, to do validation because they are just like I will say for you animal-based, you can use your 10 hands to count. I have a horse, I have a cow, I have maybe goat, I have sheep, like you can count it. But for plant-based and for insects, you cannot use your 10 hands to count out how many matrices. At the end of the day, right? How can I validate each one of this by myself? No, right? We as a community come together to help each other, be able to share the validation data, be able to share like what has been validated, what's the official method. It will help every one of us in the long run. Thank you. So for me, this is my take-home message. Basically, just remember in terms of micro, consider the intrinsic factor, right? What's your pH? What's your effect? What activity in heat treatment in fermentation? For chemical, just consider different form. Is it fresh used or concentrated? And does it come from a region? The food safety management system need to be re-verified. And also in terms of allergen, number one thing is consider cross reactivity and consider different practice in terms of allergen cleaning and all this allergen-free label before you put it. Consider all your sourcing testing. So come together, we do in terms of matrix verification and all this different microflora. What does it cost the high possible rate on the testing? So thank you. Susan, I will think I hand it back to you.
Thank you so much, Dr. Yang. Excellent presentation. So what we are going to do, we're going to introduce Elia, and then we're going to leave all the questions to the end. Just share. Dr. Elliot Schwartz is a lead scientist specializing in cultivated meat at the Good Food Institute, GFI, an international network of non-profit organizations developing the roadmap for sustainable, secure, and just protein supply. Elliot's work at GFI focuses on analyzing the technical and economic bottlenecks facing the cultivated meat industry, identifying opportunities to accelerate the industry, and educating scientists, the public, and other industry stakeholders. Elliot holds a PhD in neuroscience from the University of California, Los Angeles, where he worked with induced pluripotent stem cells to model neuromuscular disease. Please welcome Elliot.
Awesome. Thank you very much, Valeria. I will get my presentation up on the screen. So hopefully everyone is seeing that now. Once it loads. All right, let me know if you don't see that. Great. Well, I want to thank the organizers for inviting me to speak to you this morning. As mentioned, my name is Elliot Swartz. I am one of the lead scientists specializing in cultivated meat technology at the Good Food Institute. And today I'm going to be giving an overview of cultivated meat technology and contextualizing some of the food safety considerations and status of global regulation. And just a general disclaimer, these, please view these slides as informational purposes rather than any formal sort of regulatory recommendations or actions. So I'll spend about the first half of the talk really introducing you all to the cultivated meat production process and providing some of the sort of context around food safety in relation to the different stages of the process. Then we'll switch gears to talk about some of the recent developments in the United States in terms of regulation, as well as Singapore, which is one of the countries that has sort of been leading on that front. And we'll end on future directions and where things are sort of going in the near future. So before I begin, I just wanted to introduce the Good Food Institute, or GFI, for those that are unfamiliar. As mentioned, GFI is an international network of nonprofits that are working to develop a roadmap for a more sustainable, secure, and just protein supply. And we focus on alternative protein technologies like plant-based meats, fermentation-derived foods, and also cultivated meat. We work primarily in science and technology, corporate engagement, and policy work to really create an innovation ecosystem that are going to advance these technologies forward. And we have teams in different key regions spread across the globe that you can see here on the right. And we all work together pretty closely to advance this same mission. So I would definitely encourage you to visit our website if you're interested in learning about really anything related to alternative proteins. So let's talk about cultivated meat in particular. So as an introduction, cultivated meat is real, genuine animal meat or seafood that's cultivated directly from animal cells, and it can replicate the sensory and nutritional profiles of conventionally produced meat because it's really comprised of the exact same cell types that are arranged in the same or similar three-dimensional structure as animal muscle tissues. You can see on this slide a few pictures of some of the prototypes that have been developed by now over 100 different companies that span across the globe. And each of these are working at different stages to bring a variety of products, not only meat, but also milk and other animal-based products to market using this technology. So when we think about cultivated meat manufacturing, we can sort of break it down into 4 different stages. And especially in the context of food safety, we break it down this way because the potential hazards and the controls that one would implement at each stage are different. And so we'll go into each of these in more detail, but at a high level, the first stage is really focused on procuring the cells from the animal, developing a cell line, and then eventually banking that cell line that can be used for commercial production. The stage 2 is all about production stage. So deriving a large number of cells and turning those cells into the cell types that would make up your product. Stage 3 is harvesting those cells from the bioreactor vessel. And then stage 4 is all about sort of the end product formulation, processing, further manufacturing, or packaging. So let's go into each of these in a little bit more detail. So essentially, the cultivated meat process starts by acquiring a tissue sample or another biological sample from an animal. Typically, this animal is alive, and this tissue sample is acquired under local anesthesia. But in some cases, it could be a recently slaughtered animal, which could have important sort of implications for religious certifications, halal, for instance. But in either case, a tissue sample can be taken back to the lab, where it's dissociated and broken down into its constituent cellular parts. You can sort for different cell types that you might be interested in that are applicable to the process. So, for instance, muscle stem cells or fat cells, one might want to develop. And eventually, you will derive a cell line, one that can propagate in culture in a reproducible fashion under defined conditions. There's a variety of different cell line characterization that companies will perform related to understanding how the cell grows, how it consumes the nutrients that are being fed, and different omics studies to basically inform you about the phenotype and behavior of the cell in culture. And once you've done a considerable amount of characterization, you feel good about the way your cell performs in culture, you will eventually bank those cells so that it can be used in downstream production. Now, at this stage, again, I'm sort of going to talk about some of the hazards and controls that one might implement here and keep it fairly high level. Of course, there's more nuance here, but we don't have time to go into all of the details. But essentially, at this stage of the production process, the main categories of hazards include things like adventitious agents, viruses or bacteria, contaminants from the source animal. That could include things like veterinary drugs or antibiotics, as well as allergens from the source animal. So if you're taking tissue from, let's say, a seafood species, a shrimp or a fish, well, we would expect those allergens to remain present in those cells as well throughout the process. Now, these hazards aren't really foreign to the food system. There's some controls that one might think about implementing here at this stage that really focus on, conducting due diligence around the source animal. So, is the animal healthy? Was it already destined for use in the food system? There might be health records associated with the source animal, or it might have been certified by a veterinarian already. Labeling can be applied for in the case of allergens, as was discussed previously. One can apply antibiotics at the moment of sampling to reduce bacterial or fungal contamination in the tissue sample when you're taking that back to the lab. And there's a variety of different testing that can be applied once those cells are in culture to ensure that they're free of things like species-specific viruses or other pathogens that might exist. And we have good cell culture practices that can guide us generally throughout this stage of the process. Now, before we move into production, I do want to talk a little bit about the cell culture media, which is really the primary inputs that go into the production process. When we think about the cell culture media, we kind of break it down into two different grouping of components, one of which is the basal media, which are the essential nutrients that cells need to survive, glucose, amino acids, salts, vitamins, etc. And then to get cells to really grow and propagate in culture, you might need to add a variety of different added factors. And these could be recombinant proteins that collectively act as quote unquote growth factors in the cell culture. There could be antioxidants, lipids, or other ingredients that are added to the media, depending on the cell type and even the species that you're working with. Now, with respect to safety for these media inputs, there could be residues of different toxic chemicals or other bioactive ingredients that would be left or remain on a final product that could be potentially a safety hazard. There could be allergens present in the media components or the source raw materials for media components. So for instance, if you're sourcing amino acids from soy, that could be something that you would take into account. And then adventitious agents can also be a result of some of the raw materials that are used for cultured media, including plant-based adventitious agents, but also more commonly from animals if you're using animal-derived components. So some sterilization, some controls here related to media. Sterilization is a big one. Typically filtration or heat can be used to sterilize the media components as well as the water before it's entered into the bioreactor system or used in the production process. One can avoid animal-derived components, which are common adventitious agent sources. Quantification of residues in a final product to determine if anything is there. If it is, at what concentration is it there? And, is that going to be a risk to the end consumer given what we know about the consumption habits? And then finally, just general sort of proper labeling, storage, handling, et cetera, for components that go into the media in the facility. So moving forward into production, once you have this cell line that is banked, what you can do is take a vial from that cell bank and you'll generally thaw that into a small bioreactor vessel. and basically grow these cells in consecutively larger bioreactor vessels in what's known as a seed train process. And here, different companies might use different media formulations and different bioreactor types, depending on the end product that they're creating, or maybe the cell type that they're working with. Shown here in this diagram is a stirred tank bioreactor, which is sort of the most common form of bioreactor that's used in animal cell cultures right now. And there are a variety of different ways that cells can grow in suspension within this stirred tank bioreactor. So you might have cells that grow on a microcarrier, small surface. You might have cells that grow as an aggregate in culture, or even as single cell suspension, which we think is probably the most economical route that we know of, at least with current technology. And in either case, one might think about using each of these as ingredients in final products. So taking cells or cell aggregates and using those as ingredients, mixing it with other things to create downstream products. Now, at this stage, the cells are in a closed environment in the bioreactor vessel, and it's generally what you want to do is keep things from going into that bioreactor vessel. So that could be contamination from pathogens like bacteria or viruses that could enter the system either through personnel in the facility or through the raw materials that go in there, or even other physical objects that could fall into the bioreactor. And then also anything that's related to media use. This is the stage at which media is really used in the largest quantities. Now here, in terms of controls, we can implement some of the media-specific controls that were mentioned on the previous slide, general good manufacturing practices. But importantly, because these cells are in this closed and contained vessel, we have sensors and other testing that can be done to essentially monitor the process throughout the production process to ensure that bacteria or viruses aren't present, looking at things like turbidity in the media or even cellular health attributes. Now, some companies might think about not just using individual cells as ingredients, but using whole tissues to create really fully structured multicellular products. And for this application, a different type of bioreactor might be used, one that operates under perfusion conditions, and typically in the presence of something called a scaffold that could be made from things like edible or biodegradable materials, things that are already known to be food safe and familiar to the food system. There are a variety of different materials that one might think about using here, but alginate, cellulose, textured vegetable protein, these are all sort of things that have been tried already and published on in the literature. Now, essentially at this stage, what would happen is you would take those that media and the cells from your previous bioreactor, and you'd pump them into this vessel, again, the sort of hypothetical schematic shown here that contains your scaffold substrate. Those cells could then adhere to that scaffold and then grow within it in order to create a structured tissue product. So once you have either tissues or cells, essentially you need to be able to harvest them to get them out of the bioreactor. A variety of methods here might be employed, but the most common is probably going to be centrifugation or some form of centrifugation. In the case of tissues, because this hasn't really been done before, at least at the scales that we're talking about for use and implementation in the food industry, we might have to come up with some novel ways to harvest fully fledged tissues from a bioreactor, which companies are working on developing. In terms of safety here, I think really at this stage, contamination from pathogens or other physical objects really dominates. This is the point at which the cells might be more sort of exposed to open air at some point. So there's a higher degree of risk when it comes out of that closed and contained vessel. And some of the controls, as well as good manufacturing practices that are used throughout the food system, food production and processing industries can be applied here. And then finally, at stage 4, once your cells or tissues are harvested, we anticipate that this downstream processing and formulation will look very similar to that of the conventional meat industry. At this point, you essentially have cell biomass, tissue, what is known as meat. And so we anticipate the equipment and the processing to look very similar as what's familiar. But here, any hazard is related to what can end up in the final product. So things that might have entered the final the product in previous stages of the production process that you might want to do final testing for, residue testing to determine if there's any bioactive ingredients present on or in the product. You might want to confirm that the species is what you anticipate for allergenicity concerns. Apply a metal detector, other visual inspection methods for physical object contamination controls, and even cooking, for instance, can be a control when you talk about different toxic chemicals that could be present. And so this is a sort of high-level overview that talks about the general stages of production and some of the key hazards and controls that one might think about implementing. But of course, it's a little bit more detailed than this in actuality. But I think some takeaways here are that many of these potential hazards in cultivated meat manufacturing are present in other foods, food production, or other industries. And in fact, one of the recent products that was reviewed by the FDA, which we'll talk about in a few slides, this is something that they cite quite commonly throughout their application with the FDA, that this hazard or how we control for this hazard is very similar to, let's say, how we do fermentation. And another key takeaway here is that different companies are going to be using different processes and materials and equipment. We know a lot about this thus far, but we don't yet fully understand the full range of possibilities here. And so there's still a decent amount to learn about what will actually be implemented at commercial scale for these companies. So let's switch gears a little bit and talk about some of the updates in the United States and Singapore. Some background here is that back in 2019, the FDA and USDA in the United States came to a joint understanding that they would both oversee the production process of cultivated meat, where the FDA would rely on its experience looking at cell cultures to basically oversee the production process from the cell line procurement all the way up until the stage at harvest of the tissue, over which then the USDA would oversee that because it oversees meat and poultry in the United States. And one small caveat here is that in the US, the FDA actually oversees seafood regulation. And so in the case of cultivated seafood, that would be overseen entirely by the FDA. And this differs from other countries, many other countries outside of the US that have basically said cultivated meat will sort of fit within our existing novel foods frameworks. We might have to change some things within that, but in general, that's how they're looking at it. So what this means from the FDA's standpoint is that all of the cultivated meat products will go through a pre-market consultation process where companies will submit a packet of information that explains how their product's produced and what sort of controls are being implemented to mitigate safety hazards, basically justifying why they believe their production process is safe. The FDA will evaluate this at all stages of the production process and ensure that they basically have no further questions as to whether the controls or the information within that is entirely comprehensive. And additionally, the FDA, you must register facilities with the FDA, and they will be performing inspections in these facilities, especially related to things like cell banking and the production process. Now, all of this was a little bit still opaque because up until just last week, we didn't really have any information about how this pre-market review was being performed. But many of you likely have seen the news that Upside Foods in the United States became the first company to complete this pre-market consultation for its cultivated chicken product. And I think the most important thing about this in context of food safety is really open sourcing some of this information. And so Upside's own safety assessment, which is 100 pages long, is now included in public records that you can look up and see what they are, the arguments that they're making for why their product is safe. And the FDA also sort of released its own scientific memo that shows how they evaluated it and their interpretation of the data. And so it's a really rich source of information about how these products are being produced and how we're ensuring safety in their production. Now, this doesn't mean that cultivated meat can just go ahead and be sold right away. They still have to obtain a USDA granted inspection, and that includes a completed HACCP plan that the USDA will sign off on, that we believe this process is now sort of happening and taking place. In addition to that, the USDA will also approve labeling on a case-by-case basis. But we think that, at least for this specific product, it's probably not relevant because we anticipate that Upside Foods will sell this in restaurants rather than in retail as a packaged food. And so we'll probably have to wait a little bit longer to get a determination on how labeling will look in the United States for some of the first products. Now, one of the other places in the world where we know a little bit more about regulation of cultivated meat is in Singapore, because this is the only country in the world where cultivated meat is currently approved for full sale. And it's been that way since late December 2020, so coming up on 2 years now. And this is for a cultivated chicken product where it's sold in a few select locations. I actually just returned from Singapore a few weeks ago where I got a chance to try this cultivated chicken product. You can see here on the right, in the form of a chicken nugget, and also this sort of more texturized satay skewer. So it is a real thing that people are consuming today. And when this approval came out, the Singapore Food Agency released a detailed guidance document that has since been updated 4 times, which is linked here at the bottom. It's an open document that, again, is a good source of information for understanding some of the considerations in regard to food safety. And it's being updated because the regulators there are learning more as they talk to more companies. And so they're coming up with better, more efficient evaluation systems. Now, the approval process in Singapore works in collaboration with an expert panel. I believe they assembled 8 different experts from different fields to sort of work with them to evaluate the safety dossier that was submitted from the company Eat Just. And those approvals currently occur on a case-by-case basis. And one other thing to note about Singapore is that it's really a forward-looking country when it comes to novel food regulations. The government has put in money to establish this future-ready food safety hub, which will increase collaboration between regulators and industry to understand what they're doing a little bit better, but also develop the appropriate methods and frameworks to evaluate these products. And Singapore is really driven by food security as an issue, as a country that really imports over 90% of its food supply. They're looking to new technologies that they can essentially have on their own land footprint and produce. They have a goal of producing 30% of their food within Singapore by the year 2030. Now, for those looking for information on what's going on in other countries, I will point you to our global state of the policy report, which recently just came out a few weeks ago. And this contains a lot of information related to regulatory progress and also public research funding and support from governments around the world in relation to alternative proteins. And that's a free report that's available on our website. And in the final slide here, I just want to talk a little bit about some future directions to give the audience, what's to come. At the high governmental levels, the UNFAO has been working on cultivated meat, or what they're calling cell-based foods right now. This coincided with an expert consultation that just occurred earlier this month in November, where a bunch of experts from around the globe got together to really flesh out what are the key hazards and other food safety considerations for cultivated meat production in a lot more detail than what I just covered in this short talk. I was present at that meeting, and I thought it was very productive and will really contribute a lot to the open knowledge about cultivated meat. And The outcome of that meeting will actually go into a larger report that FAO has been working on that will include information of 3 country case studies for how they're regulating cultivated meat. There'll also be 3 sort of academic papers that cover regulatory frameworks around the world, a generalized production process, and also terminology, so how we are referring to this cultivated meat, which is sometimes called cell-based or cultured meat. And they also recently released a video of a facility in Israel that they toured recently, Aleph Farms, and there's a 20-minute video now available on YouTube that sort of walks through the facility as well as some of the food safety controls that the company is implementing to ensure the safety of their cultivated steak product. In addition to that, the FAO is working with the Codex Commission, is in early discussions about what new standards may be needed, or perhaps updates to existing standards that would be applicable to cultivated meat or the ingredients that would go into, let's say, the medium. And also determining when is the right time to implement some of these standards. So we don't obviously want to lock in a standard that would become maybe inhibitory a couple of years down the road when we don't know enough about the technology yet today. So I'd say these are ongoing discussions, and GFI is an observer organization within Codex, so we've been involved in some of those. And some of this work, I think, will also be carried out through collaboration within the industry. So recently, some of the largest sort of trade associations within the United States, Europe, and Asia Pacific region got together and said that they will all be collaborating to advocate for more harmonized and efficient regulatory frameworks and standards development in the future as this technology progresses. So I think a lot of forthcoming actions will be coming, and we'll as we learn more about this technology around the world. So I want to thank you for your attention, and we'll be happy to take any questions now.
Thank you, Elliot, so much for that presentation. It was very enlightening and informative. Again, if anybody has any questions, feel free to type them into the chat box, and I will field those over to Elliot. Hopefully, don't be shy. I'm sure there's plenty of questions. This is a field that's really novel and has been in the forefront, both in the mainstream media industry, academia, so I'm sure people have questions. So I see our first question has popped up. It is, what's the current food market share for plant-based food and manufactured meats? So this could be for you as well, Yan. By comparison, what are the projected market share of the plant-based food and manufactured meats in, say, 5 years or 10 years? And Yan, you can go ahead first if you'd like.
I actually don't have that number on my hand, but I can find that for you because there is a published data on that too, in terms of the market share, like what's the plant-based, and even for each one of that. There is a published data. I can send it to you later because I don't have that number on my hand.
Okay, if you could send that would be great, and we can send that out to our attendees later. Yeah.
I'll just share, at least in the United States, from a sales per dollar amount, it's around 1.4% of the meat market, but from a volume perspective, it's still around 0.9 or 1%, so it's very small. And fermentation-derived foods and cultivated meat are basically, rounding errors to zero. So everything that's, sort of quote-unquote alternative proteins right now are dominated by plant-based meats. I believe in Europe, it's still also similar, around 1%, let's say. And there are various projections that different banks have made, for instance, or investment firms have made. And we've summarized those, and they can be found online in our State of the Industry reports as well.
Thank you for that, Elliot. Going on to the next question. How far is Canada in regulation? And I believe this would be talking about the cultivated meats.
So as of now, I mean, basically, as I mentioned, Canada looks at this through their novel foods frameworks. So that's how they will be looking at cultivated meat. In addition to that, I believe they have something related to environmental impact that will also be looked at. Again, this information can be found in our State of the Policy report, where we have a summary of information. But with that said, there have been no companies. There are a few startups in Canada, but none of them have reached the stage at which they are submitting safety information to the regulators. So there have been no submissions to the Canadian regulators for cultivated meat. Really, the only places in the world that we know of where that has occurred are in the United States and Singapore as of now.
Right. So there's going to be evolution and development of regulation as we go and these products get developed, right? All right, moving on to the next question. How important do you think public or academic and private partnerships are for creating technologies for producing more complex cultivated meats, things like ribs, steaks, or any multifacial tissue products?
Yeah, I guess so. Right now, the industry has really been driven by private capital investment, and that's good because it has enabled a lot of research and development to happen for this new technology, and especially in light of some of the climate change and other global issues that are facing that this could impact. We want to have this technology out in the marketplace, and have an impact sooner rather than later. But with that said, we need a lot of public research as well to really build the foundation of knowledge and derive new technologies that are going to feed into the industry to really accelerate things. And right now, the public funding for cultivated meat and even other alternative proteins is really, really minuscule. I mean, it's on the order of dozens of millions of dollars, rather than hundreds of millions or billions of dollars that we think are going to be needed to really get these technologies, to have impact in the market. So we think about viewing the sort of things that worked for renewable energy sector as things that need to be implemented and copied for alternative proteins. That definitely includes things like public-private partnerships, one of which just happened in the United States, a consortium at Tufts University, of which GFI is a member of, that includes 8 other companies, including a conventional meat manufacturer, Cargill, as part of that consortium there. So we think that there's things starting to happen in relation to this question, but we need a lot more of it to get us to where we need to be.
Thanks for that. Our next question, could a U.S. cultivated meat company apply to regulators in other, and I believe you mean countries?
So yeah, the short answer is yes. So, and this will vary, I guess, in different regions, but the product that's on the market in Singapore is actually from a United States company. Now, I think, depending on how companies or countries will view import and export, in general, I think the manufacturing will take place within that country's borders, at least in the short term. So if you're a U.S. company, you want to market in Singapore, you're probably going to have a factory actually in Singapore to do so. Likewise, if you're a company, let's say in Europe, and you want to go to market in the United States, you're going to need a facility in the United States to bring that to market, at least how we currently understand things.
Thanks for that. And then another question, and really any of our attendees who know the answer to this question, feel free to type it into the chat if Elliot or Yan Yan doesn't know, but is the University of Guelph doing any research on cultivated meat production?
So GFI has a research grants program where we fund research projects at universities throughout the world. And we are funding research at the University of Guelph, but it's for plant-based meat. So there's some plant-based meat projects going on at Guelph. I don't believe there's anything related to cultivated meat that I know of at Guelph currently.
All right. Next question, have any world governments hinted at the possibility of subsidizing this industry in order to reduce the environmental impacts of farming, especially factory farming?
So I guess it depends what you mean by subsidizing, but certainly governments, some governments are investing in these technologies in various different ways. I think the best example recently was there's a few examples. One is in the Netherlands, where the Dutch government has put in 65 million dollars into cellular agriculture, which includes precision fermentation and cultivated meat, to really create an innovation ecosystem and supply chain that's local to the Netherlands. And in Israel, there's been a consortium that's funded by the Israeli government, an $18 million consortium that's focused on cultivated meat. That is a public-private sort of partnership there with some of the universities and companies in the country. But really what we're going to need is not only those sorts of support for R&D, but really the incentives that are going to drive new infrastructure being built. So that includes things like, tax subsidies or loan guarantees, other things that have worked for big renewable energy projects and other CapEx heavy infrastructure projects we think are going to be applicable here. And I know I'm talking a lot, so I please feel free to add in, Yan, if I'm missing things.
Yeah, so it sounds like there is some investment, but it looks like there's more that could be done by governments to support this field. Another question, is there a comparison between the overall energy, human, etc., resource requirements and impacts related to plant-based food and cultivated meat industry versus traditional food production industries?
So maybe I will take jump on this one. So on this one, you actually in the FAO report, they have very pretty picture in there to compare each one of this to see, like in terms of resource, energy, like even climate impact in there too. So the FAO report in mind, like there's a link over there. You can click on that one too. So they actually have a comparison over there. And for the last question, maybe I will add a little bit, not from government, I think from industry, right? You can see like Just Eat ADM also invest them. So they are a lot of the traditional, I will see conventional, you see it, like the meat industry also invest in, like from the private sector, invest in the startup companies.
I'll just add on the environmental note for cultivated meat. There have been a few prospective life cycle analyses that have been performed, and that information is out there. One of the studies that we helped fund was one that involved 15 different companies in the supply chain as sort of data inputs to look at what could be a more sort of future hypothetical production scenario in a large scale facility at the end of the decade. And that categorizes some of the impacts of greenhouse gas emissions, air pollution, land use, water use, etc., in comparison to conventional meats in scenarios that involve with or without renewable energy implementation that we think is going to be really crucial for getting cultivated meat, in particular, down below conventional meat production impacts because it is a more energy intensive process. So that information, again, can be found on our website and in published studies.
Thanks for that answer. And that's an interesting question because I have read articles on similar studies on plant-based milks and the difference in their environmental impact, water use, land use compared to that produced by cows. So good question. Next one, for researchers who are interested in getting into the cultivated meat research space, what recommendations would you have for getting into this sector? Are there good funding sources for this type of academic research?
Well, that's certainly what one of the objectives of our organization is, to help spur research and innovation in this sector. So there's a ton of resources on our website that are available that speak to this. We, as I mentioned, have our own grants funding program, but we also have a funding database that lists other applicable funding opportunities for researchers. We have a course, student groups that are spread across the world, 36 different student groups at leading institutions that are developing courses and other activities on campus that can be replicated at your university. And we also have a course repository with slides and things like that from courses all around the world that people are developing so that you can implement new courses into your curricula for students to take at your university. So there's a ton on our website. Please email me if you need help finding things.
Thanks for that offer, Elliot. All right, and more of a personal question. As it will likely be a while before any of us can try it, did you, Elliot, find the cultured chicken you ate in Singapore tasted like conventional chicken?
Yeah, after, at the end of the day, everything comes down to taste, right? People aren't going to eat it if it doesn't taste right or as expected. So there are two different versions of the product that were tried. As I mentioned, the chicken nugget is sort of their V1 product, and it's produced through a different process to actually create the structure. And the texture there was a little bit, I guess, more plant-based like than let's say chicken like. So less fibrous and less chewy, but otherwise, tastes like chicken because it is chicken. In this case, it's a 70%. Around 70% of the product is cultivated chicken cells, and 30% are other ingredients like plant-based ingredients. The skewer is their version 2 product, which was much more realistic, basically indistinguishable, I think, from chicken. It's chewed like chicken, tasted like chicken. For all intents and purposes, it was chicken. And they actually just released their version 3 product at COP27 in Egypt, where people got a chance to taste a more sort of fully structured chicken breast analog. So it's coming, but so far so good, I thought.
Okay, so it has a thumbs up from you. Okay, good to know. I actually have a brief question for Yan. So what I took away from your presentation was that we really need to make sure we do a very thorough and in-depth risk analysis, hazard analysis when looking at these plant-based foods for safety. Do you think there's any research hole or gap that could be filled to help industry to determine some of those risks?
Yeah, I feel like, even just from the big one is process validation, right? I think that's, in my opinion, it's like because I mentioned it's so different. You can validate it for soy, but then you go to almond, it could change. They change the whole game, right? Because so process validation, I have been several like industry roundtable. Basically, it's try to form like kind of best practice sharing of knowledge sharing in terms of the process like a validation. That's in terms of micro, like how you can validate like the micro kill. A lot of time, like I mentioned, from the ingredient perspective, a lot of people now like put a lot of attention in terms of sports. But as everyone knows, right, if you try to do a validation on that, it's not that easy. And then you resource because it's come from different country and then different ingredient. So you have to do the prevalence study, right? Do I need a 5-log kill? Do I need a let's use the raw flour as an example. Do I need to, like a chicken, have to have 5-log kill, right? Because you look at the E. coli like prevalence in flour, you look at the Germany study, US study, it's less than 1 log. So can I see like work with the academy of government said, okay, I validated for a 2-log kill, it's enough. Of 3-log kill, it's enough one, right? And then for a lot of this is like one company did one validation, but it's a extruder, it's a extraction or whatever it is, right? Nobody can do, like I said, there are so many different matrices. Nobody can do all of them, right? Because validation study is very expensive. So because it's not because the study by itself it's expensive, it's you have to stop the production, right? Stop 1 day, 2 day and cleaning and all this. That's money for an industry to have that burden, be able to validate it. So I will see from my kind of perspective, that's a big one. Everybody need to come together to see, okay, like that's the data sharing, that's the kind of like validation need to be done. Even like not only just from micro, even from your allergen cleaning, from like how long can you run? Can you run like a 24 hours, 48 hours, 72 hours, right? It's like a run validation. It's a very important part of it. How long? Because a lot of time we consider that powder, it's a low moisture food. And then you are saying, oh, the cleaning can be a week, can be 72 hours or whatever it is. It's not only from the hazard point of view, it's just how much product residue will be there. You will stop it because it's just so sticky and stuff on there. So from my perspective, I feel like the validation is a very big part in terms of all these different plant-based and even the insect part of it. Because even Elliot mentioned, right, after you do the culture meat, you actually have to go to the normal production too, right, to produce it. And the normal control need to be in place.
True. All right. Well, we probably have time for maybe 2 more questions, but if anybody else has additional questions, feel free to put them in the chat. We might do a follow-up afterwards to answer those. So the next question is, how different are challenges of introducing plant-based protein and cultured meat to the market? And feel free, either one, Yan or Elliot, to answer this question.
Yeah, I think this one, the consumer acceptance, and another one I see like from the generation wise, I feel like it's the younger generation. That's just from personal experience, and also from if anybody are interested in the consumer perspective. So I'm part of the iFish. So iFish actually have published data in terms of the consumer perspective, including nutrition perspective. Brit, that's their nutrition expert on that. She did publish in terms of the consumer perspective. I would say right now the consumer acceptance for like insect protein it's a big one for Western country, right? And also in terms of the comparison, I feel like they are still argument, but more and more people are, I think you see we published in terms of like earth friendly, people care about this, and then they actually are the ones pioneer of turning into the new technology and the new, that's not new, but the alternative options. That's from my perspective.
Thank you.
I guess the only thing I'd add is, from a technology standpoint, the extrusion or other processing technologies for plant proteins are just more mature. Like we know how to do this. Obviously, there's room for improvements, but it differs in contrast in cultivated meat, where yes, we know how to grow animal cells, but we've never really done so at such large scales that are going to be needed for the food system. And so there are sort of technology challenges that are going to be you need to be addressed in order to really scale up and get this into the marketplace in an actual measurable quantity.
Thank you. And we'll take one last question. It looks like Kathleen had her hand up. Thank you, Eva, for mentioning that. We were just taking questions in the chat. So Kathleen, if you'd like to just briefly unmute yourself to ask that question. Or not. Okay, it looks like maybe Kathleen is left. So I will then follow up. So that was a great discussion, everyone. Thank you for participating, and especially to Yan and Elliot for those great presentations. We do have one more session in this year's GFSS annual symposium. It takes place next week, Wednesday, same time, and it focuses on how to stretch your food dollar safely. We've got another excellent slate of presenters lined up on the panel for this session, so be sure to tune in. If you haven't done so already, please go ahead and register. And next slide, please. If you've enjoyed this month's sessions and would like to receive notices about further seminars, please feel free to reach out. You can receive notices about future seminars or annual symposium and other food safety related events. Just feel free to email Susan Sabatini at the email address that is on the slide. So thank you everyone for your attention today. I'd also like to thank all of our GFSS partners, the organizing committee, my co-moderator, Valeria, and again, our 2 presenters. I hope everyone enjoyed the session, and we hope to see you again next week. Thank you and have a great day.
Thank you, everyone. I think we can stop recording now.